Okay, so now we're going to talk about the formal definition of a vertical asymptote. And so the line x equals a is a vertical asymptote of the graph of the function f if either the limit as x approaches a from the left of f of x is equal to some form of infinity, or the limit as x approaches a from the right of f of x is equal to some form of infinity. Okay, and so when we look at computing this limit below here, we want to first plug in 5 into the function. And so what you notice here is that you're going to get 5 in the numerator, and then in the denominator, you're going to get 0 when you plug in. So we're in this case where we have 5 over 0. Okay, and so we haven't talked much about this yet. All right, what I did note to you before, when I first introduced to you limits algebraically, we talked about indeterminate forms versus determinate forms. And so I said to you that within the limit, if I get a over 0, where a is a non-zero number, all right, then I know technically that the limit doesn't exist. So this is in fact what's called a determinate form, meaning I know what the limit is. I know it's going to be some form of infinity or minus infinity. Okay, and so remember that if I have that the limit is equal to infinity or negative infinity, that means technically that the limit doesn't exist. All right, however, we write infinity to give the reader more information about the graph, about the function. Okay, so the idea here is instead of writing d and e, what we're going to do then is we're going to actually look at the left-hand and right-handed limits of this function, and we're going to see what form of infinity emerges for the left-handed limit and the right-handed limit. And if the left-handed limit and the right-handed limit match, then we're going to say that it's equal to that form of infinity. All right. If it doesn't, then we will in fact just say that it's d and e. But we will have shown that because the left-handed limit equals some form of infinity, or that the right-handed limit equals some form of infinity, I know that, in fact, x equals 5 is a vertical asymptote. Okay, so here, let's compute the left-handed and right-handed limit. So I have the limit as x approaches 5 from the left of x over x squared minus 3x minus 10. And so when you're doing this, you actually always want to use the factored form. So I'll make another note here. Always use factored form. Okay, so when we're considering the left-handed and right-handed limits, what we need to do is make sure that our function is factored. So here, I'm going to get that this is the limit as x approaches 5 from the left of x over, and then this factors into x minus 5 times x plus 2. Okay, same idea with the limit from the right. Of my function here. Okay. And so now what is the idea? Okay. Well, the idea is this. If I want to figure out the left-handed limit of this, what I'm going to do is pick a number that's very close to 5 from the left, considering a number line. All right, and so something that's very close to the left of 5 on the number line is something like 4.9, for example, right? 4.9 is a number that's pretty close to 5 to the left, and to the left of 5 on the number line. All right, and so what I'm going to do here is with this left-handed limit is I'm going to, in air quotes, plug in .9. Okay, and so I'm not actually going to formally plug in 4.9 that's why it's kind of in air quotes I'm plugging in 4.9. The idea here is I just want to know whether or not when I plug in air quotes 4.9, if I get a positive answer or a negative answer. All right, because I know that the left-handed limit and the right-handed limit is going to be equal to either negative infinity or positive infinity. And so if I get a positive answer, When I plug in 4.9, I know this limit is going to be positive infinity. However, if I get a negative answer, then I know that this limit's going to be negative infinity. So that's the idea there. So when I, in air quotes, plug in 4.9 in the numerator, I'm going to get a positive answer. And in the denominator, when I plug in 4.9 into x minus 5, I know that that's a negative number. However, when I plug in 4.9 into x plus 2, I know that that's going to be a positive number. And so if I have a positive number divided by a negative number times a positive number, that's going to give me a negative number. And so this is going to be negative infinity. Okay, I'm going to do the same idea now with the right-handed limit, except now I need to plug in something that is close to 5, but to the right of 5. So something like 5.1, for example. Okay, so now I'm going to plug in 5.1. And again, I don't really care exactly like what the number I get when I plug in 5.1. All right, I just want to know if it's positive or negative. And so in the numerator, we get something that's positive over something that's positive times something that's, again, positive. Because when I plug in 5.1 into the numerator, that's just 5.1, which is positive. When I plug in 5.1 into x minus 5, I get 0.1, which is, again, positive. And then 5.1 plus 2 is 7.1, so, again, positive. And so everything's positive, and so here I'm going to get that this is going to be positive infinity. And so here we see that the left-handed limit does not match the right-handed limit, and so in this case we are going to write D and E. All right, and so I did show you a case where the limit as x approaches 0 of 1 over x squared. We would say that that limit is infinity, right? Because both the left-hand and right-handed limits approach infinity. And so that's the idea why we're checking the left-handed and right-handed limit. We might not necessarily write the words D and E or the abbreviation D and E. We might write infinity or negative infinity, depending if the left-handed limit equals the right-handed limit. Even though, again, we know that if the limit is equal to infinity, we know it technically doesn't exist. Okay, so I know this is tricky, but just make sure that if you're still not understanding, you ask me some questions. Okay. So now I want to know, is x equals 5 a vertical asymptote of this function? Yes. Okay, it is, because I know that the left-handed limit is equal to some form of infinity, or also the right-handed limit. It doesn't matter in other words, it doesn't necessarily need to be that the left-handed limit and the right-handed limit equals some form of infinity. It just needs to be the case for one of them. So here, I'm just going to say yes, since the limit as x approaches 5 from the left of my function is equal to negative infinity. And so you could have also said yes, since the limit as x approaches 5 from the right of my function is equal to positive infinity. It doesn't matter.